Step number 2. Let's now take that same thing so here's A. But now let's say that instead of 2 possibilities, we now have more than 1 possibility for that second event, whatever it is, right? Because what if I didn't have 2 checkers? What if I had 3 checkers, right? Now I want to be able to control the fact that it's not just B or not B. It could be B option 1 or B option 2 or B option 3 or however many I need. Okay, so we're going to do the simple case first with just 3 of them. So this section is the first option for B. And this is why we're kind of adjusting it, because it's easier to see 3 in this way. This is the second option for B, and this side over here is the third option for B. Okay. Everybody okay with what's drawn there? So that means that B doesn't only have 2 possibilities now. There are 3 and only 3 here. Okay, but this can be extended out to more than 3. Though IB specifically states you won't be given more than 3. Okay, so in this case, the probability of A is probability of A and B1 plus the probability of A and B2, right? The intersection of A and B2, which would give us the middle, and the probability of A and B3. Now you can see how this is going to be exactly like the past one, right? We'll be able to make the exact same substitutions, right? And you can also see how this now could be applied to if I had 4 possibilities or 5 possibilities for that B. It now opens it up to allow us to consider more. Okay, so again, we're going to have the total probabilities. So probability of A, if we make the same substitutions as last time, this is just going to be the probability of B1 times the probability of A given B1 plus the probability of B2 times the probability of A given B2. This is using the same formulas as we did on the last one, and the probability of B3 times the probability of A given B3. So to further drive this home, let's consider a jar with green marbles and a jar with purple marbles. Well, a jar with green and purple marbles, okay? In fact, we're going to have 2 jars, okay? We're going to have jar A. Jar A has 4 green and 6 purple marbles, okay? Jar B is going to have 1 green and 2 purple marbles. Okay? Now we're going to make this a little bit more complex than we have in the past. We are going to take 2 marbles from jar A and put them in jar B. Without looking at them. Okay, so we're taking 2 marbles at random. I could end up with 2 greens, I could end up with 2 purples, I could end up with a green and a purple. But I don't know. And I drop them into jar B. Now, once I mix them up, I will draw 1 marble from B. And the question is, what is the probability that it is green? Again, could I use a tree diagram here? I could use a tree diagram, right? I could draw a tree diagram that shows what happens if I draw 2 greens out. What happens if I draw a green and a purple out? What happens if I draw 2 purples out? What's the probability of each of those? And then once I've done that, what's the probability that I pull a green out? What's the probability that I pull a purple out? And do that for each of them. I could create a tree diagram and work through it that way. Okay? Let's see if we can work through it this way. Okay? I'm going to give you about 2 or 3 minutes. See if you can figure out how to use this formula that we just learned. Okay? 2 or 3 minutes. See if you can use that to figure out how that helps you get the probability of having a green marble. All right? Go. All right, I'm going to talk through it now. If you want to watch, pay attention, that's fine. If you are in the middle of something and you want to keep working on it, that's also fine. But I'm going to go ahead and work through step by step what I would do. So because the question is asking what's the probability that that one drawn is green, I've defined A as being green, right? Because in the formula, PA is what I'm looking for. Okay, that means that B1, B2, B3 are the different possibilities, right? It could be green, green, it should be green, purple, it could be purple, purple, right? That was the first thing, drawing from jar A to jar B. Okay, so now I need to put all those probabilities together. So the probability that I get a green is equal to, first I get the probability that B1 happened. Okay, so the probability that B1 happened, that was that I transferred 2 greens. So what's the probability that I transferred 2 greens from jar A? It would be 4 out of 10 times 3 over 9, right? Because first there were 10 marbles, and then if the second one is also green, that's 3 over 9, which means there's a 12 over 90 chance that I got 2 greens. Okay, so I'm going to go ahead and go 12 over 90 times the probability of A given B. So if I moved 2 greens over, then jar B is now 3 greens and 2 purples. So given that that happened, what's the probability that I'm going to pull out a green? 3 out of 5. Awesome. Now I move on to the next one. What is the probability that the second event occurred? That was getting a green and a purple. Well, the probability of getting a green would be 4 over 10. The probability of getting a purple would be 6 over 9. Though it could also be getting a purple first and then a green. Right, so it could be 6 over 10 and 4 over 9, which is basically the same thing. So I need to take this and multiply it by 2, right? So 4 times 6 is 24. 24 times 2 is 48. So 48 over 90. All right? Multiplied by the probability. So if that happens, then now I will have 2 greens and 3 purples. So the probability of getting a green, if that happened, would now be 2 out of 5. So I put 2 out of 5 there. Plus, in the end, probability that event 3 happened, that I got 2 purples. What's the probability that I got 2 purples? 6 out of 10 for the first purple. 5 out of 9 for the second purple. So 30 over 90 times, if I got 2 purples, that means I still had 1 green with 4 purples, so the chance of getting a green now is 1 out of 5. Put all that together, and you get your final answer, which will be 36, 96, and 30. Add all those together. 162 over 90 times 5, 450. Anybody get me a number?
0.36.
Can I get 3 digits?
It like ends at
Oh, just 36. Nice. 0.36. Okay. Which is pretty cool considering what the tree diagram would have looked like, right? Because you would have had 3 branches and then 2 branches off of that. And so the fact that we can get it all this way is pretty smooth. Okay. Now, we're not quite to Bayes' theorem yet, are we? Right now, we're still looking at essentially the denominator, right? So we need one more step to put everything together to get Bayes' theorem.